Okay, so in this question, I'm going to show you how to calculate the pH before addition at certain amount of volume and at equivalence point. So this is a question I taken from Kenots, and as you can see, this is a reaction between hydrochloric acid and hydroxide ion, which means this is a neutralization of strong acid and strong base. Okay, and if we look at this question as well, you are given 25 ml sample of hydrochloric acid and 0.1 molar NaOH. So in this case, since we know the volume of the hydrochloric acid, so the hydrochloric acid is the one in the conical flask, and the one in the burette is the sodium hydroxide. So you're doing some titration. So of course, you know, when you do some titration, when the what we call this, when the indicator change color, means that you are reaching the equivalence point. But for some reason, before it changed the color, before it reached the equivalence point, of course, titration still happen. So let's take a look at this question. Now, number one, before the addition of sodium hydroxide, which means before you add the sodium hydroxide, what will be the the pH of the hydrochloric acid? Now we know that hydrochloric acid is a strong acid. Therefore, it will dissociate 100% to produce, sorry, I forgot, for dissociation, don't forget to add water. So it will be 100% dissociate, and we're going to get this. Okay, and thus we know that the concentration of hydrochloric will be equivalent to the concentration of hydronium ion. So pH of the solution is 0.10 molar. Now pH equivalent to negative log H3 plus negative log 0.10, and you're going to get 1.0 molar. Okay, so this is the answer for the first question. I think this one is easy before the addition, which means there's no titration, no neutralization happen. Okay, let's take a look at question number 2, which is after the addition of sodium hydroxide, 10 ml of sodium hydroxide. Now, this is neutralization. So when it comes to neutralization, the way we calculate, we must find the mole. Okay, so number one, let's find the mole first. So for HCl, we're going to get 0.10, and then we have 25 milliliter over 100, and we're going to get 2.5 exponent negative 3 mole. Okay, and we need to find the number of mole for sodium hydroxide as well, which is in this case 0.01 molar and only 10 ml over 100. So we are going to get 1.0 exponent negative 3 mole. So the first step is always find the mole. Okay. Now at number 2, react the acid and base. Okay, so in this case, this is where the neutralization happen. So for this, we have to create the ICF table, not ICE table. Okay, so we know that this is hydrochloric acid plus sodium hydroxide produce and HCl plus H2O liquid. This is aqueous, and this is aqueous. Initial value, but more, because when it comes to neutralization, never ever use concentration, okay? Just your mole. So here we have 2.5 exponent -3, but here we have 1 exponent -3. This is 0, this is none. Changes. Okay, for changes, as you can see, we have HCl, we have sodium hydroxide, 1, 1. Okay, so it should be, if it's fully neutralized, they must have the same number of mole, but in this case we have 2.5 exponent -3 for hydrochloric acid and only this amount of sodium hydroxide. So which one will be the limiting reactant? Of course, sodium hydroxide, because this is just a very small mole and it will finish earlier. Therefore, the changes will be -1 exponent -3. But since the x, or the changes, is -1 exponent -3, same goes here and here. Okay. So final, why not equilibrium? Because this is a strong acid. This one will be finished. This one will be 1.5 exponent -3 and 1 exponent -3. So this is the step 2, which is you have to do the reaction. Number 3, get the new concentration. Okay, so in this case now that after the reaction, we only have 1.5 exponent -3 moles left. So the concentration for the hydrochloric acid will be 1.5 exponent -3 mole over, you need to find the volume. So what is the volume that we need to get? It is 0.035 liter. Okay, in case you are wondering, why it is 0.035? Why it is not 25 now? You need to understand back to the question that we are now having 25 mil, and after that we add another 10 mil. So when we are talking about the new concentration, means the volume is a new volume, which is 25 mil, you add with 10 mil. So this is the new volume. New volume, of course, will give you new concentration. Okay, so let's calculate this, and this one you are going to get 0.0429 molar. Lastly, we know the concentration of HCl is equivalent to the concentration of hydronium ion, which is the new one, 0.0429 molar. So to calculate the pH, just write negative log, substitute with the value, and you are going to get 1.37, which is, there's a logic there, because 1.3 previously, before the addition of sodium hydroxide, it is pH 1, but after we add the concentration, the sodium hydroxide, the pH increased slightly to 1.37.